Good afternoon, everybody. Welcome to What the RFC, Making Sense of Syslog Before You Migrate. I'm Michael Kushma. I've been doing cybersecurity consulting for 10 years now. After the military, I started working with Deloitte for a few years where I learned my consulting chops. And then I moved to a small cybersecurity consulting firm where I did Splunk professional services on the road for about 2 years. After that, I started my own company, and I've been partnering with a company called Copper River, and we've been at the FDA since 2017. All right, so this presentation is going to be fairly in-depth, and it's going to be great for engineers and anyone who has to do this setup themselves. And the beginning includes some history and some general guidelines, but after that, we're going to really dive into the Cribl weeds. First, we're going to talk about what is Syslog and what do we do with it. Then we're going to talk about what RFC is and why it matters. Then we're going to get into the specific settings of Cribl for Syslog, and finally we're going to end with some best practices and tips and tricks. So pretty much everyone in IT should know what Syslog is. Some people might hand-wave the setup as part of some dusty checklist and you're done. But Syslog is actually a pretty big deal and can be very helpful. For example, in IT operations, you can get insight into what your devices are doing, good or bad. Information here is invaluable to ensure a good working network. The other half of that coin is security. Let's make sure nobody is hacking into our Active Directory servers. John from marketing could have been given elevated privileges on the core router. You wouldn't want that, and the faster we can find out, the better. And finally, since we're getting all these logs, the real power starts when you start to build timelines and correlate events to each other. Things can seem a certain way if you're just looking at the device logs themselves, but actually mean something completely different when looked at holistically. So hopefully, I've convinced everyone just now that Syslog is important, but what do? Do we just point devices at our log management software and everything is perfect now and you can just investigate all your issues? Well, some or most devices don't follow any kind of Syslog standard. Cribl has parsing for rules for both Syslog formats, and I promise we'll get into that soon. But a lot of times the formats sent from the devices don't even match properly. Logs are messy, they're hard to read, and unless you have very strict naming conventions, host names don't ever look the same. Time zones are marked incorrectly. That switch in the main network closet hasn't hit an NTP server in 20 years. Jim from the firewall administration team won't let anything that isn't 514 open, and the list goes on and on. So what are the solutions to this? Well, Syslog is a standard, and Syslog servers have ways to handle basic misformattings, and you can apply certain timestamping rules, but these solutions are usually very basic, and few have robust GUIs to implement these things. That brings us to Cribl Stream. So Cribl Stream is a fantastic way to solve and organize a lot of these issues. It's super flexible and customizable and can handle any format you throw at it. Timestamps are all over the place, set up rules to handle that. Also, the GUI is fantastic and makes it really easy to grab test logs, set up configurations to sample what the outputs would be, and you could even drag and drop these configuration items. All right, wait. Let's take a step back. How do we get there? Do we just snap our fingers and Cribl can do it? Not today, maybe when AI takes over the world. So let's talk a little bit about how we can use Cribl now to fix most of these Syslog problems. All right, so let's first get an idea of how we can get Cribl into our Syslog environment. So here's an example of what your current Syslog environment might look like. You have Syslog sources, which are your switches, your routers, firewalls, etc. And they're going to either maybe a load balancer or directly to your Syslog server, and then maybe the Syslog server is sending it to Splunk or Elastic or AWS or whatever. So the best way to accomplish a clean cutover is to fork. So what I mean by fork is splitting the data so your production feed continues to work as normal, but you can also start testing Cribl. Most Syslog applications should have a way to split the incoming data into multiple outputs. In our case, production data was being written to files on our Syslog server, and so we just added an extra output on the configs to send to our new Cribl hosts as well. The other option here is to set up the extra destinations on the devices themselves, but a load balancer will make a lot of this easier in the future, so if you don't have a load balancer in front of your Syslog servers, now might be the time to consider one before trying to do something like this. All right, so once you add the fork, the data will start hitting Cribl. This is the basic initial setup to get Cribl to listen for Syslog. One thing to note, if you are setting up Syslog for TCP, make sure you have Cribl listening before you fork over the data. If you don't, the Syslog output buffers can fill up and cause all of your data to stop ingesting to the original Syslog server. Ask me after the presentation how I know that. So you have two choices of Syslog strategy here, single port or multi-port. So why might you use one over the other? Well, some devices can't choose which port they're using, so you're going to be stuck with the default. You might as well just use that port. Another reason to just use a single port is the filtering strategy will be the same across the board. It's also less firewall rules to open up, so it's a little simpler. One small note here, Cribl Cloud actually does use the single port strategy. So some reasons to use a multi-port strategy. Well, pipeline routing is much easier and faster. You just point one source to a corresponding pipeline or route. You also get tagging, and you can add fields right at the source. And lastly, you get some additional metrics and logging, and probably most importantly, individual queuing, so one source doesn't affect your other sources. With that said, even with multi-port, you're very likely going to have at least some devices that can't change their configuration from the default port, so having it as a catch-all is probably a good idea either way. All right, so now Cribl is listening to Syslog. What are we going to see? Well, this is a quote about Steve Crocker, the inventor and author of RFC 1. He gave his text a humble title, Request for Comments, and made his tone as inclusive as possible. So what is RFC? Well, we won't waste too much time on these nerdy facts, but I do think that establishing all these layers explains why things are the way they are. So as I said before, RFC stands for Request for Comments. Steve Crocker, one of the founding fathers of the internet, created RFC so his team at UCLA working on ARPANET could share notes and ideas on how the early internet should work. For those that don't know, ARPANET was one of the first networks ever created, and Steve needed a non-authoritative way to share his work notes. The notes eventually became the holy grail for standards and best practices for many of the internet-related protocols today. RFC explains what the actual Syslog formats will look like, and we'll get into those specifics here next. Now, this is all important because it tells us what should be in these logs, and it gives us an idea of how we can strategize getting these logs into our log manager or SIM. Another little fun fact, Steve Crocker eventually passed the buck on to John Postel, who worked with him at UCLA. John Postel later continued on to help support the creation of the ICANN, the Internet Corporation for Assigned Names and Numbers, which some of you may have also heard of. All right, so now we're sending our data, Syslog data, over to Cribl. Cribl is eating the Syslog. Finally, let's take a peek on what these formats actually look like. First, what are these formats? Well, RFC 3164 is the original BSD Syslog protocol, sometimes called the legacy format. It has very loose requirements and definitions, but it does have some structure. It has three parts: priority, header, and message. Priority is the facility and the severity combined using some kind of magic calculus or something crazy to calculate. Okay, I'm just kidding. It's not quite that complicated, but it does mean it's not human readable by default. Luckily, Cribl does parse these fields out if Syslog is formatted properly. The next part here is the header, which contains both the timestamp and the hostname, or IP, and this is where the real problems really begin. First, let's look at that timestamp. What is it missing? Where's the year? This is the standard format for RFC 3164. This was definitely created in a time where people were not expecting to keep logs very long. What's even worse is that RFC 3164 allows for the addition of year and time zone, but no definition on how to do it. So you can pretty much expect any timestamp from any of these devices. The default also doesn't contain milliseconds, which makes it really difficult to order these events. Problem number two is the hostname. As you can see in this example, hostname is an IP. For Syslog, it can be the hostname, sometimes FQDN, and it can be IP in either version 6 or version 4 format. So it can be a lot of things. This makes it very difficult to organize. If you're using a list to filter these devices by the type, you're going to have a bunch of different hostname formats. And until they start sending it to you, it's very likely that you're not going to know what format it's going to hit you. Finally, the syslog message itself. This is pretty much the most important piece of data you're looking for. And a lot of these devices actually send the host name and sometimes even the timestamp in that message field. So that can be very useful. The message can also sometimes have a tag field, but this was never a requirement in RFC 3164, but it does touch on it in the actual document. So tag may exist, might have brackets, might not. It's really kind of a mess. All right, up next, RFC 5424. This is the current syslog format that almost nobody uses. This format is supposed to make 3164 obsolete, but it came out in 2009. So I guess 16 years isn't quite long enough to get all our devices to switch over. So 5424 was meant to correct a lot of the loosey-goosiness of the legacy format and actually create a solid standard. The format still has the 3 parts, but things have moved around a little bit, and they've added an optional structured data piece, which can sometimes have some pretty useful information. First up is the priority, which is still using the same magic math as always. But if you look close, you can already see the first difference. So all we need to do here is just enhance. Okay, this is the easiest way to find out if you're using the newer format. There is a header field called version. If it's equal to 1, you're in luck. This is a properly formatted syslog. So if you're lucky enough to be getting logs in this format, here are some improvements you're going to see. First, the timestamp is actually a requirement to be formatted with year and time zones. It also a lot of times includes milliseconds and sometimes even microseconds, which is the 3 places versus the 6 places. You also get additional fields like app name and proc ID, which were in the tag field before, but now they're actually called out directly in the spec. This may or may not be a big improvement for your logs. So using Cribl, we can parse out all these pieces if we want, or dump them on the floor and save some space. It's completely up to you and your requirements. So here is a quick peek on what those syslog parsed out fields look like in Cribl. You can see the message and the app name and the proc ID here. And you'll notice that priority isn't here. That's because, as I said earlier, Cribl actually already broke it out into facility and severity for me. Then Cribl then builds the raw field based on these syslog fields that it extracted. And in the next steps, I'll show you how I do it. Okay, so now that we know what the fields and the formats look like, let's do some basic processing. So I've built a pipeline from scratch because I'm a big custom guy, but there is a syslog pack available that can give you some ideas on where to start or give you an entire framework and you can plug and play your pieces. I've pretty much pulled a lot of this directly from the pack. So this is what I use for my pre-processing pipeline. All my syslog traffic runs through this basic structure, and it does some very basic but super important things. So let's just go from top to bottom. First, that timestamp issue I was talking about. Here, if the syslog timestamp is detected as coming in the future, I just throw it out. It's obviously not going to work for us. I can try to grab a better timestamp in another pipeline for that specific type of data. And the next 4 lines are just the way I recreate the raw data based on what syslog fields were parsed out properly. I do it this way because I don't add the host name and timestamps back to raw like Cribl does by default to save on space and licensing. However, I do add the app name and the proc ID back if it's available, as opposed to just keeping it as an indexed field because it's small enough and I think it's worth having. See, users are usually going to search for like host name equals whatever during a specific time frame, but they might not know to look for app name equals whatever, and they might just do a keyword search for SSHD or something like that. If it's in the raw data like that, they'll be able to find it. If not, they have to know the field name. So for line 6, I inherently don't trust the host names that get sent from the syslog device since they can be in so many different formats. So here, I just grab the IP from a Cribl internal field called __ source IP port. This leads me to lines 7 and 8. These are the lookups we use to map the incoming IPs to the proper source type and indexes where we want to send the data. Here we have 2 maps, one for the device to the filter name, and then one for the filter name to the source type and the index and the cluster we happen to send it to. We have 2 lookups because that's how we were doing it previously on our Syslog server. So we just wanted to keep it 1-to-1, make our swap over a lot easier. If you were doing this from scratch, I would suggest just doing a single lookup to have all the information you need to have right from the beginning. And then finally, the last line here, line 9, we just do some cleanup and get rid of some fields we don't need. I don't need to keep the original message field or any of the other Syslog related fields, but obviously you guys can do whatever you need to. So here's an example of a Syslog lookup. It'll match on the host field, and then it'll output the index and the source type and the source, and you can use those in your pipelines later. You can also see in this example there is a time zone field. That would be fantastic to use if you have that kind of information. We didn't, so we just throw out bad timestamps, but this would be a very slick way to fix these time zone mismatch issues you've seen and will see. All right. We're finally there. Cribl is set up. Don't forget to deploy to your workers, and everything is ready to go. So let's flip the switch. So a few things to note that we didn't talk about previously. During the Cribl setup, you'll need to set up where the routes are going to send your Syslog data. For us, we pointed our Cribl output to a test environment, which was a set of test Splunk indexers. This kept everything off our main environment until we were ready. And then we just, but you can have this just dumped to dev null on Cribl or send everything to production, but on test indexes, definitely up to you. So the process goes something like this. First, you need to disable whatever forking mechanism you were using. That was only there so we could look at what the logs were going to look like and configure Cribl. Next, we need to set up our Cribl environment to output to actual production. Whatever you were doing before, test indexes, test environment, dev null, it's now time to set that up to your production endpoints. Now, no data will be flowing yet. That's on purpose. We want you to do a clean swap, no duplication, no gaps, so you want to do this with the forking data off. After that, it's time to flip that metaphorical switch. For us, it was super easy. We use F5s, and the Syslog target was load balanced to a set of Syslog-ng servers. And then all we did was take it from the Syslog-ng output pool to the newly created Cribl pool. And it worked almost flawlessly, pretty much flawlessly. This is why I suggested getting a load balancer set up in the beginning, because this piece was super easy to do. After that, all your data should be going to Cribl. Now, this is where you get the real power. And you can create pipelines for each of your sources. And the obvious first pipeline should be your very heavy, high-volume data sets. That way you can save as much as possible with as little effort as possible. OK, so what can you expect to see in savings? Well, this is obviously extremely dependent on the format of the logs. But in our environment, this setup saved us space across all of our Syslog data just by removing the long timestamps and host names that we were outputting in every single log. But some of the real heavy hitters were our web proxies and our firewalls. Those alone took up about 60% of our total Syslog traffic, and we had huge reductions in both. Our web proxies were a little tricky to optimize as they were already in CSV format, so there was very little fluff in the logs. But we did discover there was a lot of duplicate pieces of data, as well as data that was in there that wasn't needed for our use case. For firewall, it was even better. Everything was in key value pairs, so like half the raw data was taken up by the field name. We moved that log format to CSV as well and saved about 50% right there. And then the next little bit was just getting rid of some of those unneeded fields. Both of these reductions were doable because of the Cribl parser and serialize functions. These allowed us to strip out all the fields in the data and then recreate raw in a more efficient format. One thing to note, after adjusting that log format, you're going to have to change your parsing rules on your search layers so it matches the new format that you've just built. But it was actually even easier than expected. When you use serialize, it actually just shows the set of fields that you're going to output. And I was able to copy and paste that list of fields directly into Splunk, and I knew it was going to match the output 1-to-1 because I had just built it. So let's talk about a few tips and tricks to keep in mind. So for timestamps, when we were using Syslog-ng, we had a lot of issues with timestamps being messed up due to some shoddy NTP settings, and it caused a lot of ingestion headaches. Because of this, we set the timestamp to just be the receive time in Syslog-ng, but now that we've swapped to Cribl, we have some options to set the time from the very beginning. So which timestamp strategy should you use? Well, if there's a timestamp in the Syslog message itself, we always use that. It will be the most reliable. It comes directly from the source application. But if there isn't one in the message, we try to use that syslog header that's there. It should have the correct information, and it's usually accurate. And if you have the time zone, it should work great. If that isn't reliable and it's not matching right, or you don't have a time zone so you can't be sure when that data actually happened, we just default to the Cribl default time, which is the time that Cribl received that log. So the case for UDP versus TCP, we enable both and say, send TCP if you can. It's more reliable, and as a security professional, I think it's more important to make sure we actually get the logs than the performance efficiency take you get when you have that three-way handshake. However, with that said, we mostly end up seeing UDP, and that's the default setting for most syslog devices. But UDP is actually really great for heavy volume data sets, so we don't really complain too much. Finally, if you do want to use the normal 514 port on your Cribl workers as opposed to the default port of 9514, you just have to set the capnet bind service in your cribl.service file on your hosts. Okay, so now I'm going to quickly, that was the main part of the presentation, I'm going to try to quickly go over some advanced configurations that might be of use. So first, these are the settings you see when you are setting up syslog as a source on Cribl. The first toggle here, proxy protocol, this allows you to see the forwarded host names and IPs instead of seeing the proxy's IP. This is important because if you plan to filter like we did and take that IP instead of the syslog header, we want to make sure this is on so it'll properly forward the originating IP. The next toggle here is single message per UDP. This toggle assumes that one packet is one message. Now, I've never personally seen a device try to send a multi-packet UDP syslog, so I just turn this on. Next, allow non-standard app name. Remember how I said in the beginning how nothing is ever compliant? Well, this allows Cribl to take those non-compliant app names and actually parse them properly. The final toggle here is TCP load balancing. This allows Cribl to balance a TCP stream so it won't pin a single CPU thread on your worker hosts. You can also explicitly set your time zone default here if you know most of your syslog devices are going to be coming from a specific time zone, but it's not super important. As you've seen, we kind of do rules for this anyway. Your TLS syslog settings will also be done here in the source configurations for your syslog. Okay, so here's how you can show Cribl internal fields if you didn't know. In the pipeline menu on the top right when you're doing your pipelines, there's a little gear icon for advanced settings. If you click that, you can toggle show internal fields. So highlighted here on your left is the source IP port. That's what it looks like, and you can see it has the IP between the pipes. We just parse that out and we use that as the host name in all of our filtering. All the internal fields will start with that double underscore. So if they have that, you'll know that it's a Cribl internal field. You may also notice here there is a field called __ syslog fail. That field is extremely helpful because it tells you right off the bat, hey, Cribl couldn't find the parsing rule for this specific format of log. So assuming you do already have some kind of syslog servers or server, here are some easy to use rsyslog and syslog-ng configurations. So here I kept all my original settings and then I added an extra logging line that included Cribl as a destination output, but had no filter, i.e. it was sending everything to Cribl. Friendly reminder again, if you're using TCP and Cribl isn't set up to already listen when you do this, the syslog server will stop receiving messages as the outbound buffer fills up. Okay, what should you do now? Well, first I'd say go ahead and start sending some data to Cribl. It's not that hard to fork your data over, and it doesn't hurt to see how easy it's going to be and what kind of savings you can achieve with your high volume data sets. Once you figure out if the juice is worth the squeeze, get a plan together. Get your change requests in place, open up new firewall rules, build out a load balancer if you need to, and then figure out what you need to do to make this work. And then finally, flip that switch and get those savings. Thank you all very much. I have a few minutes if anybody has any questions. I don't know if we have mics around.
I'm coming. I'm coming.
Thank you. Thank you for the presentation. One of the best practices both Splunk and Cribl talk about on their websites is to put Syslog-ng and a forwarder sending the data, like get Syslog-ng to write as a JSON payload into disk and forward it further. What are your thoughts on that?
So Cribl has queuing. So we treat that as good as writing to disk for Syslog-ng.
Okay. I don't think PQ works for Syslog.
Okay,
So
I'm not a Cribl guy, so...
No, because I tried source side PQ and it never worked. And then I opened a ticket and they're like, oh yeah, source side PQ doesn't work for UDP Syslog coming in. So that's where...
Interesting. Okay, I mean, that's news to me. In fact, we'll talk about
I could be
that.
wrong, but I'll check with those guys.
Yeah, no, that's a very good point. Yeah, so I'm basing it on the assumption that queuing works. So yeah, if it doesn't, that's definitely different.
Okay. Thank you.
All right, great. Any other questions? You in the front? Did you have a question? No? Okay.
I got one over here.
You're sitting behind a load balancer and you were then basing it off the source IP. Do you not get the load balancer IP in there, or is that what the proxy setting did?
Exactly. So this proxy, enable proxy protocol, I don't even see the F5 IP. It's all the originating IP addresses. That setting allows that.
Okay, good to know. I also mentioned that the single message per UDP will stop based on 1500 or basic, whatever your MTU is.
Yes.
And there are some in 5424 that will fragment and go over that. So if you have that set, that would break that fragmentation.
Yeah, if for logs that are going to be that long, yeah, I've seen that a few times where they're too long. We try to increase the actual buffer size so we get a full message instead. Yeah.
Gotcha.
If it's over that, then I mean,
go TCP.
Yeah, exactly.
Over here. I'm coming.
I just wanted to ask, did you end up making any core Linux changes to support Cribl running when you replaced your TCP servers?
As far as tuning, Linux.
Yeah, any tuning on the OS level? Like for instance,
yeah.
I know for our syslog, I've had to adjust buffers and things like that.
Yes, we pretty much have to do that kind of across our whole environment for various reasons. Yeah, Syslog, we do it for our Splunk environment as well. But yeah, the core memory sizes on Linux, I don't have the settings off the top of my head, but yeah, some of the base memory buffer settings for TCP and UDP ingestion in general for network traffic. We do have to do that.
Okay, so you did make changes, but you just don't have them here.
Mm-hmm. Yes.
All right. Well, Leslie, would you mind going back to that slide for your config? I just want to take a picture of it.
Which one?
The one with the configurations of our syslog.
Oh, okay.
It was Syslog-ng. Thank you. Yes, sir.
Yeah, and specifically this was for when we were doing our testing. We just put the block and it copy and pasted pretty much everything that we were ingesting, and it didn't affect our production workflow, but then it also sent a copy to Cribl. It worked great. You're welcome. Keep that up. All right. Thank you very much.